I'm not that sarcastic. A little bit, but not that much. Chase has 65 senior girls. If that's not true, well, 1 year they did, okay? Like I didn't say what year it was. I didn't say 2014. 23 play volleyball. And 26 play, what's the other popular school sport? Basketball. Now you do that when you get like 60, my age. Then you lawn bowl, play bridge. 31 play neither sport. Draw a Venn diagram to represent this. Now, wouldn't you be happy if your name was Venn and you invented this, and every time someone used it, they used your name? Or would you not care? Who was Mr. Venn anyway? Maybe it was Mrs. Why do we assume it was a male? But how long ago was it? Maybe it was. Maybe it was like in the 50s when the women were allowed in pubs. Okay. All right, so we know understand what's going on here? Not too complicated, right? There's 65 senior girls, 23 play volleyball, 26 play basketball, and 31, almost half of them, don't play either sport. The numbers add up. What are you thinking, Tristan? We don't add up. 23 and 26 is 49. So are you thinking 49 and 31, isn't that 80? That doesn't add up to 65, does it? What are we not coming to the conclusion of? Bingo. What if they play both? Then I would still say that if you play both, you still play volleyball, right? I'm not going to exclude you from here. If you play both, you still play basketball. I'm not going to exclude you. Some of these kids overlap, okay? So these aren't disjoint sets. There's going to be some overlap between this set and that set. So if you're doing your Venn diagram, John Venn, what year? Oh, it doesn't? Okay, well, we can assume he was at least 20 when he invented a Venn diagram, so probably 1850-ish. Maybe he was an old man, 1880. Okay. So we assumed correctly it wasn't a woman. So all they did were professional housewives, right? Back in the 1800s. Okay, so we don't want to do a Venn diagram like this, do we? We got some overlapping group here. All right. So, well, let's make it relatively nice and big. My universal set is what number? Lewis? Yeah, that's my universal set, right? I got 65. Okay. I got a set of volleyball. Let's call it V. There's 23, but I don't want to put that number there yet. And I got a set of basketball. Well, let's call it B. I do know A prime plus B prime, that's A, did I say A? V prime and B prime, not volleyball and not basketball, is 31. 31 kids don't do volleyball or basketball. They play neither, right? That says the same thing, right? And there's like, you know, because it's English, there's 10 different ways to word this. Neither. Okay, so, but what do I do here? How do I distribute these numbers in here? How many kids play both? That's the trick here, to figure that out. Okay, because I know this is 23 total, but how many are here, how many are there? I know this is 26, but how many here, how many there? Okay, let's just call this, that's going to be A, that's going to be C, and that's going to be, did I say C? Yeah. What is wrong with my brain? A, B, and C. That's, the middle one's going to be B, the last one's going to be C. Okay, so I do know this. I know the kids that play just volleyball or volleyball and basketball is 23. Okay? Because if they play volleyball, well, they might play volleyball and basketball. Are they mutually exclusive? Do we say, Ash, sorry, you can't play basketball, you play volleyball. You can't do both. Come on, give someone else a chance, would you? No, we don't do that, right? They're not mutually exclusive. They're not disjoint. How many play basketball? Well, they might have played volleyball too. That's group B. They might have just played basketball. I know that's 26. Okay? How do I figure out what B is? Or how do I figure out what A is? And there's a few ways to do this. Like if you don't really see the logic, you can use a system of linear equations. You remember doing this in grade 10 and 11 maybe? Okay, you'd need 3 sets of equations because you have 3 variables. And you can do it that way, right? But I'm not going to teach that way. It's possible. What do these numbers tell me? This is 65 total kids. This is 31 who don't play either. So, okay, what does that give me? If I go 65 minus 31, which is 34 kids, 34 kids what? Play. That's this whole area. Yeah, okay, that's right. Sports. According to this, there's only 2 sports. That's our universal set, right? There's no cricket, no croquet, no badminton, no soccer. As far as this situation's concerned, I've only got 2 sports, volleyball and basketball. That is the number of kids, senior girls, that, well, that's all the groups, isn't it? That play volleyball, basketball, or both. Okay? Because again, these sets and everything that isn't that set, that has to add up to 65. It has to add up to the universal elements here, the universal set. Okay? So in other words, I could go 34 is A and B and C. I know that's looking like another linear equation, and I said I wasn't going to do that, but does that make sense? Yeah. Yeah. Okay? Again, the whole thing here is A and B and C plus 31. That's everything. That's got to equal 65. Okay? So 65 minus 31 is 34. That's got to equal all this. I still don't really know how many play both, or how many just only play volleyball. I could have put the word only here, right? That's only volleyball. Because if they play both, well, then they're not going to be in this group A, are they? They're going to be in B. Only basketball. I don't really want to tell you. I mean, does someone see how, using some deductive logic, how I can come up with both? Lewis?
I took 34 and then subtract that.
Okay, if I take 34 and I subtract 23, what does that leave me? 65 minus 23 minus 26? What does that leave me? What does that mean? There's lots of numbers. We could throw them all around. Well, I want to subtract this and add that. Okay, but what does it mean? Let's start with that. If I go 34 minus 23, what is this? This is the kids that play this, or both. What is 23? This is the kids that play just volleyball or both. So let's look at the equation. If that's 23 and I substitute it in there, 34 is 23 plus C. What does C mean? That's the ones who play just basketball. What does C have to be here? Well, I said I wasn't going to do it like that, but there it is. There's an equation. What's 34 minus 23? 11. What's group C? That's the kids who just play basketball. Okay, so if I know 34 play volleyball just, or basketball just, or both, and I subtract the kids that play volleyball, that means just volleyball or both, I got to be left with this area, C. That's the kids who just play basketball. Okay, according to that, that's 11 kids. Okay. I could also say, well, 34, let's subtract the kids. I'll do this with color this time. Let's subtract the kids that play basketball and both sports, because I know that number. That's 26 kids play basketball. That's either just basketball or both sports. If I subtract 34 from 26, I'll be left with kids who just play volleyball, right? Which is 8 kids. Okay. I see quite a few people trying to look at this and process it, figure it out. And it may not come today. Sometimes it's stuff like this. Maybe you got to sleep on it, and tomorrow you look at it and go, ah, bingo, got it. Okay? All right. So 8 just play volleyball without playing basketball. 11 just play basketball without playing volleyball. How many must B be? Okay, it's got to add up to 34, right? 34 minus 11 minus 8. 34 minus 19 is 15 kids. Okay? Then you check. It's got to add up to 65. Okay? 8 and 15 is 23, and 11 is 34. Those are the kids that play a sport, or both. Plus 31, that's everybody. That equals 65. Okay? It works. All right? So that's some kind of, well, call it logic. So one other thing to look at here. Somebody said, what happens if I do that? What happens if I do 65 minus these? Okay? Let's look at it this way. If I add those and I minus 34, what is 49 minus 34? Okay, now that's not as intuitive as maybe what we kind of just talked about a minute ago. That's a formula. Okay? The number that play volleyball and basketball is equal to the number that play volleyball plus the number that play basketball minus the number that play volleyball just, or just basketball, or both. Okay? I hope that kind of makes sense, but that's a formula. Okay? We'll see it again tomorrow. So this is it's called the rule of inclusion and exclusion. All right? And what it says is we have to include the ones that play one sport, the ones that play the other sport, and then we have to subtract the ones that play both because you can't include them twice. That's why the first thing I said was, do these numbers add up? And you said no. Well, they do if you don't count them twice. Okay? The group that plays both, you can only count them once. That's why we write the Venn diagram like this. Okay? Okay, 161, 2, 4.